Hi, I'm Catherine and I'm a postdoctoral research fellow at the University of Southampton. Today, I'm going to share with you a bit about offshore renewable energy foundation systems, so what they are, why they're important, and how they work.
Offshore renewable energy infrastructure is critical for decarbonising our energy supply and achieving net zero targets. Offshore renewable energy offers enormous potential for harnessing clean wind, wave, and tidal energy resources. But these devices need to be supported or held in place by foundations that are embedded into the sea floor. That foundations are expensive. They account for around a third of the offshore renewable energy infrastructure project costs. And this is because they are large structures that need to be manufactured, transported to site, installed in the sea floor, and then reliably support the offshore renewable energy device over its operational lifetime. So today, we're going to look at 3 different kinds of foundation types that can be used in offshore renewable energy infrastructure applications. First of all, the pile. It's very long, typically up to about 2 to 3 London buses in length. The second kind is the screw pile. It's a variant of the pile as it has a helix at the end on the tip. And the third kind is the suction bucket. It's shorter and stubbier than the other two, up to maybe 2 London buses in length and up to 1 to 2 London buses in diameter. These foundations are installed in a variety of ways. So, for example, the pile is driven down into the seafloor by applying a vertical force. Screw piles are screwed into the seafloor by applying a torque or a force that causes rotation. Suction buckets are a bit different. So first they're placed on the seafloor and then the water inside the bucket is pumped out, causing the bucket to sink into the seafloor. So which of these foundation types do you think needs a higher installation force? So to demonstrate the installation process, we have some small models
Of the 3 types of foundations, the pile, the screw pile, and the suction bucket.
and we're going to get an idea of the sort of installation force that you need to use for each of these 3 models. We have a box of sand with some water in it with some scales on the bottom, so we can find what that installation force is going to be. So first of all, let's try the pile. So what I'm going to do is just push it in, and we're measuring around 700 grams of force to get it in this deep. Okay, now let's try the screw pile. So I'm going to twist it in to the wet sand. About the same kind of depth we got the pile in. And there I measured about 300 grams of force required to get it in that deep. And then last of all, let's try the suction bucket. So I'm going to have to give it a little bit of force just to get it onto the seabed. And to do that, again, that's about 300 grams of force. Once it's in there, we can then use this to suck it in. And as you can see, it just goes straight in. So now that we have our foundations installed, what are the pull-out capacities like? Well, in reality, these foundations tend to have pull-out capacities of around 250 tons. That's equivalent to the weight of up to 2 blue whales hanging off the foundation system. Cool, so now that we have the foundations installed, let's now have a look at their pull-out capacity. So with me, I have a spring balance, which I'm going to use to pull each of the foundation types out. So it's attached, and I'm going to pull. Yeah, I read about 50 grams of pull-out force required. Okay, so now let's try the screw pile. So we're pulling, we're still pulling, and there it's come out with about 200 grams of force required. Now, let's try the suction bucket. Okay, I start pulling. And it's coming out, and I'm reading about 200 grams of force required. Maybe more like 250 that time. So the suction bucket and screw piles had the most pull-out capacity, and this makes sense, as their pull-out capacity depends on the interaction that they have with the surrounding soil. So first of all, with the pile, pull-out of the pile requires overcoming the friction between the side of the pile and the surrounding wet sand. With the screw pile, pull-out also requires overcoming the friction on the side of the pile, but it also needs to overcome the weight of the sand that sits above the helix. And finally, with the suction bucket, to get pull-out, we need to overcome the friction on the outside and inside of the bucket, as well as the suction that's generated inside the bucket.
So you might be wondering how we actually test these kinds of foundations under more realistic conditions. Well, we use the centrifuge apparatus. And you can come and visit us and see the centrifuge apparatus in person and learn more about it. So yeah, please come visit us at the Southampton University Science and Engineering Festival.